Greenplum chats. There's so many I can't even remember what number it is now. But we're here to talk about performance tuning tips and tricks on Greenplum chats. We have our usual friends Ivan Novik and Cesar Rojas, and joining us are our expert guests Scott Kahler and Ken Dowling. Scott and Ken, why don't you introduce yourselves really quick, and then we'll get into the subject.
I guess I'll go first. So I'm Scott Kahler. I work as part of a data platform engineering team with Pivotal. I'm trying to think now. I want to say I've been working with Greenplum specifically for 6 years now. Start to lose track, part as a customer and part on as being part of Pivotal. So I started as a customer, enjoyed it so much, I wanted to show it to other people. So that's kind of what I do. Greenplum, Hadoop, the platform, servers, all that kind of fun stuff.
Okay, so Ken Dowling just dropped out because both of us are operating from the basement Wi-Fi, which is not working quite wonderfully today. But Ken Dowling's been working with databases and warehousing for at least 20 years. I know he was at Informix, Netezza. He was at Greenplum long before I was there, and he's been at probably hundreds of customers' houses. So great guy to be able to get on the show here and talk about performance as long as he can get his Wi-Fi up. So talking about green performance, you know, what I always heard from people out in the field who are experienced is that there's a bunch of big knobs around performance for Greenplum, and if you can just tune some of these 3 or 4 big knobs, then most of your performance issues will be taken care of. So Scott, you want to kick it off and talk about what are some of these big knobs that really impact the performance of a Greenplum install?
Okay, so I guess when we talk about performance tuning and stuff, one of the major things that we come across are distribution, the partitioning, how you're actually storing your data, the parameters you're using to store it. Then we can talk about loading and indexing, but I'm going to say that the first 3 are probably the biggest knobs that people need to look at, and that's really about how you're setting up your data inside the database.
So you're talking about in the DDL, setting up you said the first 3 were?
I'd say distribution, partitioning, and then the different storage parameters using for your database. So in that case, we're talking about whether you're storing it as heap, append only, you're using compression, columnar, those types of things.
Okay. So Ken, you want to tell us a little bit about setting the right distribution for your data and why that's important?
Yeah, sure. The distribution strategy is key in terms of making sure that each node or each segment inside of the Greenplum database has about the same number of rows. It's never going to be exact and identical across all of the segments in the database, but the goal with a good distribution strategy is to make sure that each one has about the same amount of data for any given table. And when you think about that, which columns then should you use? And I guess first, before you even go into columns, there's 2 ways you can do that. You can just say, hey, set it to random. And at that point, the database just spreads the data, again, fairly evenly across all of the segment servers.
So let me stop you there. So what's the downside of random then? If you have the access to random, why not just set everything to random and you'll have even?
The downside with random is that when you access that data and you're going to join that data to another table, you're going to have to move it regardless.
Okay.
So if you use random and you do a join to that table, data is going to have to move. It's not always necessarily a bad thing to move data if the data set is small. And the query engine tries to move the small data sets and leave the large ones in place. But random guarantees data movement with joins.
So if I port a schema from Oracle and make every table random and then do lots of 10-way joins, then what would be the impact?
The impact would be, the performance would be pretty poor on that because every join is going to have to move data. And you're going to build a result set for the first join and move that to a second join, to a third, to a fourth. And every time you join, you're moving data.
Okay.
And the other downside with moving data is that it also, we call that a motion operator inside the query plan. And the other downside with that is you increase the number of processes on the back end, the number of slices, we'll say, so that the optimizer creates slices, and those are in turn create processes on the system for doing the query execution, and that just puts an extra burden on the operating system at that point, because now you've got an additional workload for the operating system as well.
Okay. So if it's not random, then what should be the strategy?
Without the other option is to distribute on a specific column or set of columns that you identify as you create the table. The benefit there is that, or the way that works then, is we will hash on that data and determine where that record belongs. Oh, that goes to segment 0, this goes to segment 27, this goes to segment 32, etc. And again, the goal there is to distribute on columns that have high cardinality, so that those...
And just for spot checking my database knowledge, what does that mean, high cardinality?
High cardinality means a lot of distinct values, a lot of unique values in there. You don't want to distribute on a column that has true false, because you're just going to go to 2 segments at that point because you only have 2 values.
Okay.
So you want a high number of relatively
lots of different
values. Yes.
Okay. So should I just go through my whole schema and determine which column has the most cardinality and then pick that for everything?
No, I mean, that would obviously give you the best and most even distribution, but what you want to do when you're coming up with distribution strategies is look at how you're joining to that table. So if you're going to join on column A, you may want to, and that's your most frequent join column, that makes for a good join candidate. With random, we mentioned that we're going to have to move for every join, move data. If I can distribute my first table on column A and my second table on, let's say, its value, or its instance of column A, and then I join those 2 tables on that column. So column A from the first table equals column A from the second. Both those are my distribution strategies. We get what's called co-location, and what that means is that data does not have to move between segments to facilitate the join. All the join is local. All the data is local for that join to happen.
Okay. And does to your knowledge, will the optimizer understand the fact that does it need to understand the fact that the columns in the join are matching, or is it just a side effect of the fact that the keys dynamically match and that there's not a lot of motion?
The optimizer will take into account that this table is distributed on this column, this table is on the same column, I'm doing an equijoin on that, and it's aware of that, and it'll do all of that automatically for us.
It'll do local processing.
Correct. The one thing you have to be sure of in that case is that if you've got column A in one table and column A in the second table, that they are defined the same. So that, let's say they're both defined as integer columns.
Exactly.
Or they're both
the same,
defined
right?
as big ints. If one is an integer and one is a small int or a big int, the data will hash differently to different places. So the key to co-location and for all of your join columns throughout the DDL is to ensure that they have the same column definition.
Okay, that sounds good. So it sounds like getting the right distributions for all of your tables will prevent lots of crazy motion around the cluster. Why don't we go to Scott now to talk a little bit about partitioning. So Scott, what have you seen as kind of best practice around partitioning data?
So partitioning, when you look at partitioning, what you're doing is you're slicing your data up into subsets that you want to access. Most commonly, it's done around like timestamps. So you have your constantly rolling in data, and you want to have a table that holds all the data, but really for most of your queries, you're looking at maybe like the last 7 days, let's say. So what you're going to do is you're going to use partitioning to set up separate subsets of data where you only work with the chunks of data that you're using in your most common queries. So this becomes kind of important to understand your data model. So maybe date time might be a field in your database, but it's not what you're really working on. If you're scanning all the dates that are in there all the time, that's not going to be something you want to partition on. If you're doing it, most of your queries are going by specific clients. Maybe if you're scanning all the data and you have partitions for time, instead you want to go for clients because you're not getting any partition elimination. And that's what partitioning does, is it says, okay, I'm going to split this data set into 100 separate partitions. And if I can look in my query and see that I only need 4 of those sections of that data, I will only scan through 4 of those partitions rather than all 100. So ideally, you're going to reduce the amount of data that you're scanning off of disk by partitioning it. It ends up being kind of you really have to understand your data model, because partitioning is good if you can reduce the number of things that you're going after, but you also don't want to over partition, right? So if you're scanning all your data all the time, what you do is if you set up, like let's say you have a year of data and you're scanning it all the time and you set it up in daily partitions, instead it would be better off being one partition where it's one file that you can read through, as opposed to separate partitions where it needs to open that file, read it, close it, go to the next file, open it, read it, and iterate through it like that. So you kind of have to really look at how you're accessing your data and what your queries are doing to make the most out of partitioning.
So what recommendation can we make around when should we not partition? When should we partition? And if we partition, how small should we break up the chunks?
So I would look, what I do when I talk to customers about that is I look at your most common sets of queries, okay, and talk about what we're looking at is a weekly, we're looking for the last week when we run a large set of our queries. And you're probably loading on a daily basis. So that's what you want to have, is probably daily, usually ends up when you're doing time series for the queries that you're running, because usually people are looking at daily chunks. Now, if you're a company that's doing, if your queries are in 15-minute chunks, maybe that's where you need to go. You need to look at your window where your most common queries are hitting. And then if you start looking at, okay, well, I've got queries that are going out to a month, or also looking at 3 months, what you want to do is potentially roll those smaller partitions into larger partitions, because that's one of the cool things you can do in Greenplum Database is you can say these first 4 partitions are daily, or the first 30, then we roll like last month up into 1 partition. So if we have queries that are going deep, we can roll that into larger partitions.
So as a quick kind of check, in what scenarios would you say, like, hey, you can clearly say you should not partition? Like, is there any kind of way to know this is really not a good candidate for partitioning, so that we don't over partition tape?
Yeah, if your partitioning isn't going to get you any elimination, then it's not a good candidate for partitioning, right? So if I'm going, why partition it by day if I'm going to go in and all of my queries are going to be on client looking at the whole thing?
What about like dimension tables, for example, where they're for example, like let's say you had a user ID table, right? That's storing all the users in some system, right? Would that be a good partition?
Probably not. Usually it's your fact tables that you're going to want to partition into smaller chunks. Dimensions tend to end up getting scanned as a whole, so I would usually leave those as one solid piece.
Okay. Ken, do you want to add anything on your experience with partition?
Sure, yeah. And Scott's definitely hit the highlights there. The one thing in terms of kind of quantity of partition, and again, it's kind of a rule of thumb, is around 1,000 partitions is where I try to.
For one table or for a database? For
one table.
Okay.
Is where I kind of draw the line, where you start to question, am I getting into to have too many of those? And to Scott's point, it really boils down to the overhead of, well, I've got to open that, scan it, close it, open it, scan it, etc. Now, I've had a table with 17 trillion rows in it, so when you get into those, trillion row tables and multi-trillion row tables, you need to, kind of bump that upper limit of partitions just because of the overall size of the table. But ultimately, that's kind of my rule of thumb, where if if I'm working with a customer and they say, well, we've got 5,000 partitions in this table, that's an immediate red flag for me to investigate what's going on there, what led them to that decision. Are they really benefiting from that more than the overhead is costing them?
Okay.
Right.
And
I
what
guess,
about, go
to
ahead.
tack on to that, I think, when you're looking at what your partitions, you want to have multiple thousands of records. We're talking, I'd say 20 to 50K, and some of this depends on the size of what your Greenplum cluster installation is. But your partitions should be in the tens of thousands of records, right? If you're making partitions that are hundreds of records or tens of records, you are way too small.
Well, yeah, I mean, hundreds of records sounds crazy, but is even 10,000 high enough, or?
I think even higher. I even go into the millions for that, and maybe billions again, depending on it's all relative to the overall scale of the environment. But yeah. And then a couple other thoughts on that. In terms of candidate columns for partitioning, when I talked about distribution, I mentioned you want to look at what columns you use to join your data. And those are the candidate columns for distribution strategies. For partitioning strategies, you want to look at what columns are used in your where conditions. So what are the filters on your queries, or the filters that you apply to when you access that table?
Why is the where clause important for picking a partition column?
Well, that's where you're going to have, let's use a data example. If you want to go after January's data, your where clause is going to have that filtering component to it. You're going to say, give me all the data where date is in January. And then if you're partitioned by month, let's say, the optimizer can look, or the execution engine can look and say, I just need to get January's data, so I'm going there.
So what would happen if I had a table with 1 trillion trades? Let's say we're a stock exchange and we have 1 trillion trades, and I partition it by trade ID. And then I say, select where the trade date equals January 1st, 2010.
In that scenario, you're going to scan the entire table, 1 trillion rows.
All trillion rows.
All trillion rows.
And then what would happen if I partitioned it by day?
In that case, you're going to just scan the exact day that you want.
And ignore all
ignore everything else.
I see. So the where clause will get interpreted to say, that's my filter. And that should match to filter out partitions you don't care about.
Exactly. Yep.
Okay.
Yeah, so I guess the thing there is, for distribution strategies, look at your join columns, and for partitioning strategies, look into your where clauses for your filters.
Okay, let me restate that again. So for distribution column, check your what?
Your join conditions.
Your join conditions.
How you're joining.
Right? So what are you joining on, so that you're not doing crazy motion around the cluster? And then for partitioning column, look at your
filters in your where clause, and that's what's going to help you get the partition elimination when you access the data.
Right.
And the goal of those,
especially for those big fact tables, right?
Exactly, yeah. And then for dimension tables, I tend to not worry about partitioning at all, and I tend to not worry too much about even the distribution strategies. I worry about this for the fact tables.
For the fact table, because those are the expensive.
Those are the big ones. If you've got a 10,000 row table and you're going to join that to a trillion row table, who really cares how the 10,000 row table is stored? It doesn't really matter.
Okay.
Hey, Ivan and Ken and Scott, I don't know if you guys have had much of a chance to watch the chat, but you got quite a conversation going. Granted, looks like you've got some experts in the audience that are talking to each other.
Actually, can I unmute somebody?
You can, yes. Actually, you can.
I see a guy here that looks familiar. Let me see if I can locate him. There's a guy here named Luke. Let me see if I can enable his mic.
When you're trying to get Luke set up, one of the things I want to throw in there when we're talking about partitioning, part of the thing about partitioning is your maintenance schedule too. If you're doing things like rolling off a month of data, that's also something to take into consideration. I was just saying, when you're doing maintenance on your table and you're like truncating data off, that should be taken into consideration in your partitioning schedule too. It's a lot easier to drop a partition. So if you know that you're rolling off a month, then maybe monthly partitions make sense. If you know you're rolling off a week at the end of it, then it's going to be a lot easier to roll off a week of data in a weekly partition than it's going to be to roll off a week of data out of a monthly partition. So that's going to drive some of how you do your partitioning also.
Right. Any other gotchas or need to knows about partitioning to watch out for?
One last thing on partitioning for me is there's the capability to use a default partition. And what that basically is kind of a catch-all, meaning I'm inserting a row into the database or into that table, and it doesn't fit any of my other partitions. It doesn't meet any criteria for any other partition. So you can kind of put it in this catch-all default bucket. I try to not use default condition or default partitions in the tables. And again, for me, it's my best practice from the standpoint of I'd rather have something error loudly and up front when I first try to insert that row than have it silently put things into that default partition.
Mm-hmm.
And the reason for that is when we execute a query, for every query, even if we're getting partition elimination on all the other partitions, that default is always scanned.
So can we disable the default partition and just prevent anyone from using it so that we don't end up doing extra scans on the data that's in there? Or is it not a good idea?
Usually I just don't, if you don't define it at table creation, it doesn't exist and it's not there. So that's, quote unquote, the way I would disable that. And the main reason I learned from this one on experience, I was at a very large customer. They had one of their fact tables with a default partition. It had a few 100 million rows, and about 80% of those ended up in their default because they didn't pay attention. They didn't watch it, and they had some issues with how they defined their partitions and how their ETL processing.
So is there any reason that we can't, as a best practice, just try to not have default partitions? Is there any major benefit to always having one?
Like I said, I prefer to have the error up front. If I don't have a default defined and I can't insert the row into one of my defined partitions, I will get an error up front. I prefer it that way, but every customer use case is a little different, and it really boils down to having a process around monitoring that default.
If you have it.
If it's there, you have to kind of keep an eye on it to make sure it's not overflowing with data.
Okay. So guys, let's quickly cover, Scott, let's quickly cover the storage parameters because I want to cover all the big knobs and not take up too much time from folks, and there's a couple of other bits left remaining. So Scott, you want to talk about the storage params?
Okay. So the two big storage parameters that I look at are row-based versus columnar. And that's a massive one, and the great thing is Greenplum does both of them. And I would say most people understand a row-based scheme where when you go to scan the data, you're scanning everything that's in that table. You're pulling in all of the rows. Columnar is when you create a file for each column that's in the table. So if I do a select AB from table, the only files that I'm opening are the ones that back values A and B. And if there's a CDEF, I don't open and read that data in. So in tables that are really wide and you're doing high selectivity, columnar can be a godsend in how much data you're actually pulling off of disk. The other really big knob, I would say...
Scott, hold on a sec, Scott. What about the reverse of that? So what if I create a 500 column table and I always query it to select star?
Then you're probably going to want to stay row-based, because what's happening, it's like partitioning. This is one of those things you have to be very careful of when you combine with partitioning. You're creating a file for every column. So if you have a 500 column table, you have 500 files. So if you do select star, when you do that, you're opening up 500 files, probably 6 to 8 segments on each server that you've got. You're opening up a lot of files. And if you partition on top of that, there's all of that for each of the partitions. So you end up opening up a lot of files if you're selecting star from that. So at that point, stay row, where it's just all in one file and you're blowing through it that way.
And what about the compression aspect? Is there a compression difference between row and column?
Yeah, so there's some cool things that you can do with a columnar like run length encoding, you can get fantastic compression ratios using that in column based. Because if you have a column that's all zeros and ones mainly, or potentially you go into a lot of customers and it's just all zeros, run length encoding compresses that down to virtually nothing. So when you open up to read that file, it's a very minimal read in order to get that data. And then compression, the data types seem to be much more similar in the same column. So the compression you'll get will be much better when you go columnar.
Okay. Let's see, we got a couple questions. What's the max columns? I think Lewis pointed out 1,600. And then what's the tipping point between percentage of column selection and the choice between row and column? So if I'm querying half of the columns on a 1,000 column table, should I be doing columnar or row? I could tell you my answer on that, which would be half of 500 columns. I would say that's a lot of columns to read in single, because each column is stored separately, right?
Yeah.
So I would say if it's a partition table, I would probably go row based. If it's a columnar, well, yeah, if you're not partitioning, you'd be more inclined to go columnar. And then I think it's also going to depend upon what the data types are that you're getting out of there too.
And what about data loading? So have you ever seen people do different types of storage for loading and then transfer to another type as the data gets older in the older partitions?
Sure, yeah. The one great thing with partitions is you can have what's called a hybrid partitioning strategy. And that hybrid strategy is you can have newer data with one strategy. So let's say daily partitions. And then as your data gets colder or older, you can switch that to, let's say, a monthly, or then you can switch that to quarterly. But it's all part of the same overall table. So the end user has no idea. They just select from the table, and the execution engine takes care of the fact that recent data is daily, and then warm data is weekly, monthly, cold data is then quarterly. And then the really cool thing is we can then go to an external partition. So let's say you wanted to keep 7 years of data online, but only really 3 years or 4 years in the database. You can put those oldest 2 years on external storage, define external partitions that access that data again seamlessly to the end to the user.
The part that I forgot or missed was, so then what about the very first partitions that you're loading into? Like if you're doing micro batch every minute or 5 minutes, what type of storage would you use for the quick micro batch partitions that are consuming the incoming flow? Like which would be faster for loading into, do you think?
Row or column or heap in that scenario, for the micro batch, you probably want to do a heap table, which is kind of the original structure that we support, kind of the Postgres legacy structure, and with that, not do compression, etc. Get the micro batches into the table and then do some processing to move that into a more optimized access storage. So in the micro batch in architecture, you want to have the load be prioritized for the most recent data. But as that ages, whether it's an hour or a day, then you can flip that to something that is more access optimized. So flip that into, let's say, an append optimized table with the correct partitioning strategies.
Hey guys, I've got a question I'm trying to reconstruct out of the chat here. Sean is asking whether or not filters run before or after the column reassembly, I presume in the columnar table case.
Right, and Luke said if not, it should filter it as the IO comes. If not, it's a bug, and I would agree with that. As it scans there's no index or anything, so it has to read in this case, so it has to read every row of the columnar table. But as it comes, it can filter. So for example, let's say you had a 500 column table and you said where gender equals male. So would you reconstruct all of the rows and then filter them, or would you reconstruct only the half of the rows where the filtering had matched? And I think the answer, as Luke said, is it'll.
Yeah, Ivan, can you hear me?
Yeah.
We're hearing you
Oh,
excellent.
good. Okay. Yeah, good. So yeah, the question is whether or not projection pushdowns are implemented, and I believe they are. It's a quick question that Venki could answer. Ken, you might know. But if it's not, if projection pushdowns aren't, it could be done. So it's a good question from the field or from Sean. I don't know the answer.
I'm pretty sure that that already works. I can't say 100% based on my memory, but as you said, if it doesn't, it's a bug. It should be working already. So, yeah.
Guys, I think we could be going like this for about 4 hours minimum.
That's right. So let's move on to, I want to show Scott's demo.
Yeah.
So Scott had a couple-minute demo.
And one of the things I wanted to talk about was when you guys were talking about hybrid tables where we've got heap up front and then append only on the backside for loading. It also becomes important for customers that are possibly looking at modifying the last 2 or 3 days of data. We did that at the place that I worked at. We had heap for the first week and we append only after that because we knew we would get in and muck with the data for the first week following it coming in, but then it would be pretty set after that. So anytime you're going to be doing a lot of modification of the data, you think you're going to be updating it, those should be heap tables.
Okay.
All right. So let's see here. So I guess what I was going to show, the data that I've got here, let's see here. I've got 2 sets of data. So I've got, there's a game I play and it's got creatures in it, and then I've got players in it, okay? So this would be the kind of data that you want to bring into your database to analyze, right? And you're trying to figure out what's the best way to store this data. Now my big set of data has got about 2 billion rows in it. So I want to extract, so what I did for purposes of the demo and talking about data is I created a partition table. What you can see here is I've got 106 child tables because I partitioned it by my time, by day. So that way I can extract a couple of days out of it. So I extracted a week of February out for us to use and take a look at. Okay. So the first thing I want to take a look at here is our distribution. All right, so in my creatures table, every creature's got an ID. So that's kind of the natural distribution key, because ideally there's a lot of them and they spread out and they're unique per creature. So I've got a creature and a daily point of what it does. Actually, I think it's every minute it records what's going on. Now, what somebody might think about doing is saying, okay, well, I want to distribute by name, which could potentially, you could take that to maybe that's like a client code or something like that. If you have a lot of clients, you might say, okay, well, maybe a good distribution key is by client because I've got a lot of clients. Okay. If I take a look at this, let's see here, what do we got? Features, Feb. So I've got just a week in Feb of creatures, and I can see that this one's distributed by creature ID. I have one that's distributed by the name, and I have one that's distributed randomly. Okay, so the question is going to be which one's going to give me the best performance if I want to plow through this table. What you want to look at is, in my case, I'm just plowing straight through the data, so I'm going to want equal amount of data on each segment. So in that case, if I take a look at name, what you'll see is there's a lot of skew. And the best way that I found for getting skew ID, and I gotta get my spelling right because I misspelled segment here. There are some views in the database for doing this. But really, when I'm working with one table, this is the way I go about seeing what skew looks like. Ken, is that normally?
Yes.
Yeah.
So you don't use the tool, you're not using the toolkit view, guys. You're just saying, just tell me the number of rows per segment.
Yeah, so this is an important hidden variable to know right here. People should know this one. This is the segment that the data exists on. So right here I'm doing a count of the records in this table by segment ID. And you can see that they're fairly close here, right? Which is good. I would say that it's not optimal, but it's pretty close to good. One of the things that you will do when you work with Greenplum, like I'm taking this from a different database and pulling it into Greenplum. Actually, in the other database, the location is a separate table, but I'm denormalizing that into one table. And both of those are done by creature ID. So if I was doing this, well, creature ID and time. So if I was doing this where I had those two as separate tables, and I would be joining them together, for sure this is the way that I would go, where I would partition by creature ID, because I know that join is going to be very, very important. That's going to keep it local, right?
So,
but in this
Scott, the join you're saying is between which column in creature and which column in player?
Oh, it's not. I'm actually denormalizing the data. So
Okay.
in the original database that I'm abstracting from, there's a creature table and there's a position table. If I was bringing those in as separate pieces, and they would both be done on creature ID, I would definitely be distributing them by creature ID, because that would be my join point.
Right, you distribute on your join column and partition on your where column, right?
Right. And I guess that's what I see a lot out in the field when we're doing implementations, is you're taking a database that's gotten too big for an SMP database, right? So they've done some normalization of things to try to keep the data small. And Greenplum's really good at scanning data and plowing through it. So there's probably going to be some denormalization that you're going to do. If you keep it in that normalized form, then you have to really look at how are all these normalized tables joining together. Those are potentially highly useful for what your distribution keys are going to be.
So this question, Scott, Ken, Luke, normalized versus denormalized, what do you want to try and do as much of either normalizing your tables or denormalizing, and kind of why yes or no?
So my opinion on that is Greenplum handles denormalization better than a bunch of normalized tables. What we tend to see in Greenplum clusters is you have a lot of I/O and a lot of disk. And it's able to plow through data on disk a lot faster than if you're trying to pass a lot of data back and forth across the network. So my take on that is to try to reduce some of those numbers of joins. A lot of times that's like dates being changed to integers, then having a date table that's got all of them in there. If you're not getting anything special out of that, then I would take the original value and push it back into your table and denormalize it. I'd be interested if somebody else has a different take on that.
No, I would agree with that, Scott. And the optimizer can handle a third normal form design. But that leads to what you've referred to as a join-heavy plan. And with a lot of joins, you're going to have a lot of data movement and just a lot of additional work. So that kind of going to, let's say, a more dimensional model, like denormalizing a bit into dimensional, a snowflake, or even getting rid of the snowflake aspects of it, can definitely improve performance just from the standpoint of you're eliminating some of the joins. But obviously, we got to weigh, if there's a maintenance aspect there, et cetera. But I've done operational data stores that are third normal form fine on Greenplum, but
Yes.
you just have to understand that there's the
So
optimizer is going to be a little more join heavy, and it deals a little bit better probably with the dimensional.
So it works fine, but it works maybe faster if you denormalize. And then do you see that with like migrations from other database systems a lot? Because of the different architecture of kind of original single node databases?
Yes.
Yeah.
Right, so if you're migrating a customer from Oracle or SQL Server, they would basically be join heavy?
Yes.
That's true.
I see that a lot. A lot of people are trying, and that's kind of one of the things about going to a parallel architecture is usually space and compute are things that you can add on, whereas in a single node system, a lot of people are heavily constrained by space. They need to fit, reduce space as much as possible. So they're making their tables. That's where I see a lot of normalization coming in, is how do we make this fit into a smaller box, and don't necessarily need to do that in the Greenplum world. Or they're trying to get all that to be able to load into memory, a smaller factor. And it's just a lot easier to plow through the data for us than it is to try to squeeze it down as much.
It sounds to me like this is a good topic for a future Greenplum chat, is getting into the details of actually migrating.
Yeah, and one other question I wanted to hit, Greg, before because we are getting pretty long on time, is any other highlight cases you've seen where you've been to a customer, they struggled with performance, and we've come in and made modifications, and they've seen real relief? Can you think of any good examples without naming names of cases where we've done schema changes or changes to the way they do ETL or anything, any kind of good war stories you can mention?
I'll start, I guess. The key things we've kind of touched on around distribution strategies and partitioning strategies, but those can have, if you do that poorly, it can really, really hurt performance. And I've had good success where you go into a customer site and you look at how they're partitioning their tables or distributing their tables, make a few minor changes, really, change distribution column, maybe change data. So I had customers where they had columns that they were joining on, and they were all defined
different column types, like a float with an integer.
Yeah, well, the decimal and an integer and a big int, and and that kind of lack of discipline around the detail can really hurt. So from my standpoint, some of the big gains we've seen with these topics we've discussed is really around discipline, understanding a little bit about how Greenplum works, like we've discussed today, and really making sure that you're kind of following these best practices.
How about, have you ever seen anybody with OPS? Okay, you've probably never heard of OPS before because I made it up, but over partitioning syndrome. Actually, I think someone else made it up, but have you ever seen a customer with over partitioning syndrome?
I'm sure I have. I know I've seen them up in the 5,000-ish range and worth.
Or how about 100,000?
I don't think I've ever been unfortunate enough to see that.
Scott?
They exist.
Stuff that I see is normally people who have 6 months of data partitioned by date, and after the first month, they're really working with a monthly basis. So there's no reason for the last 5 months to be in individual data partitions. I've seen that go out to 3 years before, right? So you're causing your system a whole lot of overhead to keep that in partitions when you're totally not accessing the data in that manner.
That's a great candidate for a hybrid strategy. Keep the current data in day partitions, and as it ages, migrate it into monthly partitions, etc.
And then as it ages, then external
partitions.
Yeah. So Greg, are you there? Do you want to ask any remaining questions? The chat started scrolling too fast for me to read it. Anything else you saw there, or any call to action you want to mention?
So what's this best practices doc I was seeing some a little bit of conversation about? We should probably mention that briefly.
Right. So full credit to Cindy Lee for putting together from all the different field engineers and collecting and creating the best practices guide. You've got it actually showed up here. I learned what this bit.ly thing is. It allows us to create our own little URL. So bit.ly/greenplumbp. You can go to that link at any time and just get the best practices for Greenplum Database. And it's in very short bullet form to say, these are good things, these are bad things. This, if you follow these best practices, you'll be performing way better than if not knowing about it. So to check out the best practices guide at bit.ly/greenplumbp.
I can imagine we're going to have this conversation again, and maybe we'll go deep into a chapter or two onto the best practices there.
Absolutely. I think performance is, one of the main reasons that you buy a fast data, so it's worth talking about numerous times and continuing to strive through all means possible to get the most performance out of your database and out of your data. We should definitely continue to.
Very good. So shall we call an end to this Greenplum chat?
Sounds good. And in the tradition of Pivotal Labs, we can end this stand-up with a clap.
Oh no, I got something better to end it with. We'll talk to you all later.